All right. State the necessary conditions for resonance frequency to occur in an LRC circuit. One, what happens to the current at resonance condition? Hence, derive the expression for the resonant frequency. Now, this is an IJMBE question for 2024, question 16A, Roman figure 1. Now, the first part here is at resonant frequency, what is the condition for resonant frequency to occur? At resonant frequency, 1, you must have it that the inductive reactance XL must be equal to the capacitive reactance SC. This is one condition that is necessary for resonance to occur. Or you can also say that the circuit must be a purely resistive circuit. Once you have a purely resistive circuit, it is also condition for resonance to occur. Then the next part is what happens to the current at resonance condition. At resonance condition, current is maximum, nothing more. That is the conclusion of that. Then the last part, hence, derive an expression for resonance frequency. From what we have here, which is the condition for resonance to occur, we can derive an expression for resonance frequency. Recall that inductive reactance is 2 pi FL, while capacitive reactance XC is 1 over 2 pi FC. Take note, this F that we have here, the frequency, this is equivalent to resonant frequency. So if we equate these conditions now together, that is XL equals to XC, then for the XL, we have 2 pi FL, for the XC, 1 over 2 pi FC. Then what do we do at this point? F is same thing as F here, which is same thing as F naught. So you have this to be 2 pi F naught L equals to 1 over 2 pi F naught C. Recall, all we're asked to look for is the resonance frequency, F naught. So at this point, we'll cross multiply. If you cross multiply now, you are going to have 1 equals to this and this multiply. 2 times 2 here will give 4. Pi multiplied by pi, pi squared. Then you have F naught multiplied by F naught squared. Then you have L times C, LC. All we're asked to look for is the resonant frequency, which is F naught. So try to make F naught the subject of formula by dividing both sides by 4 pi squared L and C. So you have 1 over 4 pi squared LC equals to 4 pi squared F naught squared LC over 4 pi squared LC. LC cancel LC. 4 pi squared cancel 4 pi squared. So you can have it that F naught squared is 1 over 4 pi squared LC. Now, what we have to look for is not the square of the resonance, but the resonance frequency. So I need to take the square root of both sides. Take the square root of both sides. That will give square root of 1 over square root of 4 pi squared LC. Square here cancel square root. So you are left with F naught equals to square root of 1 is 1 over, I can split this into 2, which is square root of 4 times square root of pi squared times square root of LC. Okay, so at this point you have 1 over square root of 4 is 2. Square cancel square root here, you are left with pi. Then here you have root LC. This expression here gives you the expression for the resonant frequency, which you can just put out to be F naught equals to 1 over 2 pi root L and C.